This is Britt Caswell with another example video. In today's video, I'm covering example 5 from section 5-1 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to use nth roots to solve equations. Alright, so in general, the only reason why we use nth roots is because we have polynomials that have those high exponents. Okay. Now there's not really terrible much to these problems. They're very kind of basic. Once I show it to you, the first one, the other ones kind of just fall in line. So whenever you have an exponent that's really high like this, and we know we need nth roots, okay, we just need to get x alone. That's kind of our goal. And so I can't get rid of the exponent on x until I get rid of every other thing that's on there. So I need to get rid of any addition or subtraction first, and then I need to get rid of any multiplication or division, and then I can deal with that exponent. Okay, so to start this problem out, I'm actually going to divide both sides by 2 because the 2 is being multiplied to the x to the 5th. So what that does is that leaves me here with x to the 5th equals, and 64 divided by 2 is 32. Now the way that we counteract some kind of exponent here is we're going to take the root that's the opposite. So I'm going to take the 5th root to get rid of it. Alright, so the root and the exponent cancel out, and I'm left with x. And then, 5th root of 32, so we're going to break that apart. I know 32 is 8 times 4. And 8 is 2 times 2 times 2. 4 is 2 times 2. So the 5th root of 32 is 2 because I had 5 2's there. Now it's worth noting, kind of an aside here, I guess I should say. If I have like x to the 2/3 equals some number, the way that you get rid of that 2/3 is you raise both sides to the reciprocal. So I would raise both sides to the 3/2 in order to get rid of this, because 2/3 times 3/2 is 1. And so then I'd be left with x to the 1st equals whatever nonsense you get on the side there, okay? So just be aware that that's how you would get rid of a rational exponent. But these ones, Savvas gives you just really nice, friendly problems here. So again, we want to isolate the variable here. So before I can get rid of our exponent, I need to get rid of that multiplication. So I'm going to divide both sides by 5. So this leaves me with x cubed equals, I don't know what 320 divided by 5 is. Let me use my calculator. 64. And then to get rid of that cube, I'm going to take the cube root. So here, the root and the exponent cancel out, leaving me with x. And the cube root of 64, I happen to know is 4 based off my experience, but let me show you how to get there. So 64 is 8 times 8, and 8 is 2 times 2 times 2. So I know that 64 is 2 to the 6th. So I need sets of 3 to be able to remove things from the house. So I'll be able to remove 2 2's. And that's where the 4 is coming from. Alright, now this last one is a little bit different. And the reason why it's different is that the exponent here is even. If ever you have an even exponent, you need to look at positive and negative solutions. Because, for example, 2 times 2 is 4, But negative 2 times negative 2 is positive 4 as well. So you can have a positive and a negative solution to these. Just be aware whenever you have that even exponent to look for it, okay? So I'm going to start out the same as I have been, where I divide out the number being multiplied to my variable. So I have p to the fourth equals 162 divided by 2 is 81. Now 81 is 9 times 9, which means that 81 is 3 to the fourth. Alright, so getting a little ahead of myself. I got too excited. So I'm taking the fourth root of this stuff, right? So my p to the fourth is now a p, and I'm looking at the fourth root of 3 to the fourth. Now because I'm taking that even root, I'm going to put a plus or minus here, okay? And the fourth root of 3 to the fourth is 3. So my p-value is positive or negative 3, which is easy to see with these factor trees, because if I changed all of these, getting color, if I changed all of these to negative 3, I can work my way back up the chain, right? So negative 3 times negative 3 turns into a positive 9, and then 9 times 9 is 81. So you can kind of see going backwards up through the tree, which is really nice there. But there it is. That's how to use nth roots to solve equations. Until next time.